So now we can do some examples with some more elaborate simulations. Suppose a couple plans to have children until they have a girl or until they have 3 children. What is the probability they will have a girl among their children? So at first this might seem like a little bit more of a difficult probability to compute, but no worries, we can use simulation to try to estimate it. So first we need our probability model, and so I need to give you some assumptions. We're going to assume the probability of a girl being born is 0.49, and the probability of a boy is 0.51. So the probability model then is probability of a girl is 0.49, probability of a boy is 0.51, and successive births are independent. Now, I have to give you those probabilities so you can set up the rest of the probability model, but I gave them to you here. They'd have to be given to you in homework if you were expected to do a problem. Some people are surprised to find out that boys are born at a higher rate, but it evens out towards adulthood to a 50-50 population since boys engage in more risky behaviors in general. So step 2 is assign digits. So here our probabilities have to be written to 2 decimal places, so we're going to want to use 2-digit codes to simulate births. So let's do our normal strategy and start at 1. We could start at 0 or any other number, but I just like to start at 1. And we'll go all the way up to the 2-digit number 49 to denote a girl being born. And then we'll do 50 through 99 and 00 to denote a boy being born. And now we get to repeat many simulations. So let's copy down some digits out of the table of random digits. And I have one right here in front of me. So we're going to use 71709, 77558, 00095, 32863, 29485, 82226, and 90056. So we've copied some digits out of the table of random digits, and we'll just do as many simulations as this list allows. And let's start at the beginning. The first 2-digit code is a 71, and according to our step 2 assignment of digits, that falls in the range of the digits that the codes that denote a boy. So that means a boy is born. The next 2-digit code is a 70, so that means another boy is born. And in this birthing plan, they stop when they have a girl or when they have 3 children. So they've had 2 boys, so we're going to go ahead and look at the next 2-digit code, which is 97, and that is also a boy. Now this couple stops because they've had 3 children, and that's what was in the birthing plan. So this couple, our first repetition of our simulation, did not have a girl, so we're going to give it a minus. Now the next simulation starts with a 75, so that's a boy. They're going to keep trying. The next 2-digit code is a 58, which is a boy, so they're going to keep trying. And the next one is a 00. Again, that's in our list of codes that denote a boy. They've had 3 children, so they're going to stop, and they did not have a girl. Alright, so our next repetition of the simulation starts with 09. 09 is in the range of the 2-digit codes that denotes a girl. Now what's the birthing plan? They're going to have children until they have a girl or until they have 3 children. Since this couple got their girl, they're going to stop right away, and they resulted in, yes, having a girl. The next simulation is 53, which is a boy. The next 2-digit code is 28, which is a girl. They had children until they had a girl, so they stopped. and that's a plus. They had a girl. The next two-digit code is a 63, which is a boy, 29, which is a girl, and this couple was supposed to have children until they had a girl, or until they had 3 children. They got their girls, so they stopped. The next two-digit code is a 48, which is in the range of the assignments for a girl, so they stop. 58 is our next two-digit code, and that's a boy. 22 is a girl. So this couple stops because they had their girl. 26 is our next two-digit code, which is a girl right away, so they stop. 90 is our next two-digit code, which is a boy, and 05 is a girl. So this couple had their girl and they stop. And that little 6 lonely digit that's left, we just won't use it. We don't have enough to do another repetition of our simulation. Now, of course, in practice, we'd want to do a lot more simulations than this, but again, these are tedious by hand, so I think you have the idea. And so based on our very few repetitions, we can get an estimate of the probability of having a girl using this birthing scheme. So our estimate of the probability is going to be based upon the fact that we had 7 out of our 9 repetitions result in having a girl. There are 7 pluses out of the 9 total repetitions that we did. And so that's 0.78 or 78%. So that's our estimate of the probability. If we were to do many more simulations, maybe 1,000, we could feel more confident that our estimate of the probability is very close to the true probability. And speaking of the true probability, we're going to teach you a tool right now so that you can calculate the true probability on your own. A tree diagram is a good way to organize probability spaces when they seem a little more complicated. We're going to have different stages of a probability model illustrated by branchings on a tree. Multiplication of the branches are going to denote intersections of events, and adding the resulting intersections probabilities is going to give us the probability of unions. Now we're going to use a tree diagram to compute the true probability this couple will have a girl. We're going to use this space left on this sheet of paper. Pretty much all of it's going to be used, so try to draw to the same scale that I'm drawing so that you can fit everything on your paper. So what's the first stage for this probability model? They're going to have children until they have a girl or until they have 3 children. So the first step is having the first child. And when you have your first child, you can either have a girl or a boy. Now, if they have a girl, they're going to stop. So there are no more branchings coming out of this path. If they have a boy, they're going to try again. So if they have a boy, they're going to have a second baby. Now, what was the probability of having a girl to start off with? It was 0.49, and a boy, 0.51. So we can label those on there. And again, if they have a boy on the first try, they're going to have another baby. So again, they could have a girl or a boy. And the girl happens, again, because it's independent. It doesn't matter whether they had a boy or a girl on the first try. It's still a 49% chance of having a girl and a 51% chance of having a boy. Now, if they travel down the boy on the first try, girl on the second try path, they're going to stop. So our tree diagram ends there if you're on this path. If they went down the boy on the first try, boy on the second try path, this birthing scheme says we're going to try again. So once again, you have the third baby, and you could have a girl or a boy. And again, since successive births are independent, the probability is the same, 0.49 and 0.51. There we go. Now, what is our question of interest? We want the probability this couple will have a girl. That's what we're trying to estimate. So we need to just pay attention to all the branchings, all the paths that lead to having a girl. We can have a girl one of three ways. Either having a girl right out the gate, or having a boy on the first try and a girl on the second try, or having a boy on the first try, a boy on the second try, and a girl on the third try. So these three paths that are denoted by the asterisks are the cases where you can have a girl. Notice my use of the words or and. They can have a girl on the first birth, or have a boy on the first birth and a girl on the second, or have a boy on the first and a boy on the second and a girl on the third. We're going to use those when we compute our probabilities. So first of all, let's write down the probability of having a girl right out the gate. That was 0.49. Now we want to write down the probability of having a boy on the first try and a girl on the second try. Remember we said we could compute intersections by multiplying up the branch, multiplying all the way through that path. So this probability, when you're reading it from a tree diagram, is simply the probabilities that lead to the end of that path times each other. So 0.51 times 0.49. And the third path that leads to having a girl is having a boy on the first and a boy on the second and a girl on the third birth. And again, to get this intersection, we multiply up the path that leads to this asterisk, that leads to this event. So that's 0.51 times 0.51 times 0.49. And we can copy down the calculations. 0.51 times 0.49 is 0.2499. And 0.51 times 0.51 times 0.49 is 0.127449. So we've taken care of all of our words and. We've used multiplication. But notice, we can have a girl by landing on the first path, or landing on the second path, or landing on the third path. Remember, the word or means to add. And these are disjoint events because we can't have landed on the first path and the second path at the same time. So the way that we get our total probability of having a girl is by adding the probability of having a girl right away plus, notice the word or, the probability of having a boy on the first try and a girl on the second try, or by being on that third path, the probability of having a boy on the first try and a girl on the second try, a boy on the second try and a girl on the third try. And so we see that we can add our intermediate probabilities from up here to get this answer. So it's 0.49 plus 0.2499 plus 0.127449. And when you punch that in your calculator, you're going to get 0.87. So now you have the tools to compute the true probability rather than simulating this event. The probability of having a girl under this birthing scheme is 87%. Notice that when we did our simulation, even though we only had 9 repetitions, we got fairly close to it, 78%.